Good morning, everyone. Welcome back.
Good morning.
Good morning. So I hope my screen is visible and I'm audible. Let me just check the. Good. Okay. So yesterday we spoke about just the concept of what is SD-WAN, SDN network. We have not even started with SD-WAN. So today, let's see. We will see the comparison before we can start with SD-WAN. So is there anyone new or joining today?
Yes, ma'am. I'm joining today, ma'am. Sumit.
Yeah, Sumit. Okay. So
Good
you've
morning, ma'am.
already received the drive access, I believe, right, Sumit?
No, ma'am, I haven't. No,
Oh,
ma'am, I haven't.
okay, okay. So just remind me by end of the class. I will.
Sure, ma'am. Sure, ma'am.
Yeah.
Thank you.
All right. So yesterday we discussed about what is SDN and what is the difference between a traditional network. So just a comparison we saw yesterday, correct? So today we will talk about the architecture, more about the SDN. So we are still with SDN network. Okay. Now layers, we all know the layers. We have discussed the layers in the times of CCNA. So we have seen CCNA, we have spoken about the 7 layers, correct? So now in SDN network, let's see, similar to that, not similar, but you can relate it with it. So SDN, now we have 3 layers here. Okay. So SDN topology, it works with this 3 layer. So let's understand this. So you have application layer. Then there is control layer. And there is infrastructure. Now, as we know that the control plane is now separated from the devices. We have taken out the control plane in the SDN network. Okay. Now the device which you have in your office location. Okay. So if you look at this diagram, so see, these are all my networking devices. Okay. So consider all the networking devices, all your basic infrastructure, all your LAN networks. Okay. All your firewalls, all your PCs. Okay. They fall under the infrastructure. Infrastructure, the basic infrastructure, the basic topology, you can say, that fall under your network. Okay. So this is the infrastructure layer. Okay. So physical interface that comprises of network devices and cable. Basically, all your hardware devices. Okay. Now this devices is blank. They don't know anything. They just behave as a data plane. Correct? This is my data plane basically. So their job is to receive the instruction and forward the data accordingly. Okay. So that is what is left is with this infrastructure layer. Okay. Who receives? How do they receive the instruction? From the brain. Correct. So this is my control layer, brain. So control layer, this is the land of control plane where all our controllers reside. Okay. Now we have removed the C from this part. Now the C is over here, the control plane. So here we have all different kinds of controller. Okay. So this controller will give the instructions towards all this infrastructure device. Okay. Now, how will this control plane become active? Okay. So we have to give the configuration setup, correct? So how can we give it? Through the application. Okay. So what happens is this application layer means like in OSI. How will you relate it? What is an application layer? OSI. What does your application layer do in OSI? Give me few features of application layer.
Interacts with users. We provide interface of access, just
Interface,
like
correct? User interface.
interface.
You can interact with the software. Same thing. Same thing. So when we talk about application layer, so this layer gives me the access to access the device. Basically, it will give me here, when we talk about specifically about SDN network, it can, now SDN, it's not only GUI based, we have both GUI as well as CLI. So basically, it will give me the access to my device, okay? And this application layer, as the name suggests, now there are apps. There are multiple apps available. Just to give you an example. Now, we can log in through to Facebook, through Instagram, as well as Facebook's, LinkedIn, whatever we have. So we have two options. We can log in with web browser, or we can log in with apps. So what do we prefer? Apps. It is friendly, user friendly. It gives a good user interface. Correct? Same thing. Now there are multiple applications available. Okay. So now this is engineered. Okay. So this area, this is where most of the brain is now working. If you talk about different brands, okay. So this is the open area to develop as much innovation as possible. So this is where people are working to develop more apps. Like for example, if I want to give an example, there is load balancer app, completely different dedicated app for load balancing, to monitor your bandwidth, to monitor your CPU health, correct? So there are different automation apps. There are automation apps. There is networking monitoring apps to check the monitoring part of your network, okay? So there are various applications that is kept available to us, from which we can do whatever changes or whatever behavior we want to install in our devices. So whatever application of, let's say, for example, this is policy enforcement app. Policy enforcement means you are creating some policies, some ACLs that you're creating. So you will access this app, you will do some configuration here, you will create some ACL, you will define some policies. Okay. So this policy that we are creating here, this is the user, this is us. Okay. So whatever policies that we are creating here is then pushed on to the control layer. Okay. Control layer is my brain. So it will create your forwarding intelligence. Okay. So from this controller, then it is pushed on to the respective device infrastructure. Okay. So how are they communicating with each other? Through this APIs. So there are APIs here. So this is all automated. Okay, so it is already pre-configured. It comes with all the pre-configuration. It's come with all the automation already installed. Okay, so we don't have to do anything over here. Okay, so this is basically called as the application layer and the control layer. They basically, here it is called as northbound interface. Okay, northbound interface, which connects your application with the control layer. And control layer is connected with the infrastructure layer with the southbound interface. Okay. So why this is differentiated? Because of the APIs here. So here in the northbound, basically it's a REST API that is used. Mostly REST API. Here you have different APIs working, that is OpenFlow or Netconf. Okay. So there are different types of APIs which are working, which helps in forwarding that information towards the infrastructure layer. Okay. So this is how basically the SDN architecture is set up. So control layer, this is the land of control plane. Now this is control plane. Now this is something where it might differ. Okay. So this is like, for example, Juniper might have some different configuration, different setup over here. Cisco, now as I said, Cisco SD-WAN, when we talk about SD-WAN, Cisco has many controllers. There's not only one controller, there are many controllers we manage. So that is what we will be discussing. Now Cisco has various kind of controller. Juniper may have some dedicated controller, which we might use for different purpose. Okay. So this is where they're customizing their own brand. Aruba might have different. Okay. So different providers is now they are concentrating on this, how they can improvise, how they can be better in the market, competitive. Okay. So this is the basic infrastructure of an SDN architecture. Now, let's understand the limitation now of traditional network. Okay. Now, traditional network, when we talk about a traditional network, it's always, you will always find there's a comparison with MPLS. Okay. So now what is MPLS? What does the MPLS do? Why is it better than internet? First of all, why is it better from internet? Why do we prefer MPLS? Why not internet? Why not ISP? You guys have done the advanced, I believe. It is faster, correct? Secure.
So a dedicated line
Correct.
in terms of security, it's reliable as compared to open internet.
It is reliable. Correct. So that is faster. Label switching.
It is like private band, ma'am.
Private, correct. We use private network over there. Correct. So this is why we prefer MPLS. So when MPLS, no, before MPLS, they were different architecture. What was that? I am forgetting the name. Before MPLS, what was that? If you guys know. HDLC network. There are where ATM networks, correct? So when MPLS came in, so that is when, like, so now MPLS was faster. So people switched on to MPLS. Okay. So now when SD-WAN is in market, so there's always a comparison between SD-WAN and MPLS. Will this take over MPLS? So the answer is no. It may or it might not. Okay. Basically, your SD-WAN uses MPLS also. Okay, but it is not completely reliable on MPLS. So there is two different terms I'm using here. It uses MPLS, but it is not relying on MPLS. Okay. So we all know what is MPLS. It is faster because it doesn't go for layer 3 for forwarding the packet. It doesn't do an IP lookup, basically. Correct? It looks at the labels, label switching. It will check the label and it will forward the data. Correct? And it is secure. We are using a private network over there. Correct? We create tunnels. It is secure. Correct? And it is reliable. Right? Now, what is the disadvantage? That we need to understand now. What is the disadvantage of using MPLS? Okay. So now see, consider this is your setup. Okay. So this is maybe one of the sites. So this is my branch office. Okay. This is my branch office. Let's say this is my data center. Head office, and this is my data center. This is all my servers, all my web server, email server, my important server is your data center. All right. And these are my branches. And this may be work from home people. Okay. These are my sites. These are my branches. Okay. So now you have taken an MPLS setup. Okay. You have purchased this. Now MPLS you have to purchase. It is highly expensive. Correct? This is expensive. So now what will happen? Now this site, how the data goes. If this person or any user wants to travel to internet, how it will go? It will go via data center. This side, via data center. This one has to go via data center. If you want to access internet, a data center. If you want to access cloud, any feature of the cloud, you have to go via data center. Everything, you have to go via data. In fact, if you want to speak to other site also, via data center. correct? So if you're going everything via, why data center? Why is it? Why I cannot go directly to internet?
Because all the websites or corporate data sources are in Excel.
Correct. It is basically over here. That is one of the reasons. What is the primary reason? Basic. Security.
There is only one exit and entry point for the data. Maintaining that would be easier.
Yeah, ease of data maintenance. So everything rather than, having it distributed. So basic. Now this is it may be centralized. All my data can be in head office. It can be distributed as well. Okay, it's not necessary. All the companies can afford this. Okay, if you talk about startups, okay, basic startups, it's not possible for a startup to have a dedicated data center. Now this is also expensive. It involve cost here. Correct? So if you talk about big, huge players like Google, Google server or different, all your Citrix server, Cisco, they can afford this data center dedicated. Otherwise, it can be distributed also. So if it's distributed, all the more challenging to maintain different location. Okay. Now, if it is one point of contact, so now understand, major reason is my security. So consider this is bank. Okay, it's a huge bank, HDFC Bank. Okay, so all my Ashish is smiling. So this is my main data center. Okay, so for bank, something for like HDFC, what is the main priority of the bank? Security, correct? For the customers, my data should be secure. So it's all involves money transaction there. So highly sensitive, correct? So if the branch will go directly to the internet, what will happen? Internet? Who's present here? Our favorite?
Hacker.
Correct?
Hackers.
So gone. The bank, HDFC is gone. It's compromised. Correct? So we cannot afford this kind of setup. Okay? So if, like, as I said, if the data center is here, I can have my firewall setup here. But the company may or may not afford such kind of infrastructure. If they have it, then they can. If they don't have it, if my everything is here, so here, it has to be here. So basically MPLS setup is such. MPLS, you have a hub and spoke concept. So you create a hub router, then you create a spoke router. So why do we do that? So that everything can be forwarded from one single point of contact. Correct? So this is my concern. So this is how my data is flowing, mainly because of the security purpose. I have all my firewall set up here. So all my traffic is getting directed like this. So if you want to connect to an internet through data center, if you want to access something from Gmail, G Drive, Google Drive, anything, if you want to go to cloud, anything, you have to go via data center. Now, what if the data center crash? Natural calamity, cyclone or tsunami, and it crashed. What will happen? One, HDFC Bank will be not available for a few days. No money, money crunch, no ATMs available, all gone. Correct? So if this goes, my everything will crash. Correct? So this is, you can say, one of the biggest disadvantage. So what is the disadvantage of a traditional network? Availability issues. Availability issues. Forwarding all the traffic via data center creates a single point of failure. If this one goes down, my work by my complete setup is inappropriate, like it will go down. I will not be able to do anything. Correct? If this one fails, so everything will crash. Nothing much I can do about it. Right? Latency. What do we understand by latency? Round trip time. Correct? RTT, round trip time. So if I am going from NH to my place, so how much time in a perfect world? Perfect world means no traffic. So from here to come back, return, round trip time. Correct? So that is the round trip time. How much time it does it takes? If I'm sending you something, how much time you're taking to reply? That is called as round trip time, right? So if everything is going via data center like this, so this is loaded, correct? Everything we are creating one single point of contact, single point of contact. So what will be the round trip time to get just to access the internet also? My traffic is going from here, correct? So it will increase the round trip time, increases the round trip time. Correct. For example, now let's say if I want to give you an example for let's say Swiggy. Okay, so when it's new, when it is launched, so it might receive lesser traffic. So it can operate on that bandwidth. So as like there is more demand in the market, more customers start using Swiggy. So it has to cope up with the requirement. It has to increase the bandwidth. Correct. So there will be more latency. Correct, on Swiggy's part, right? So latency issues, traditional network. Cost. Just the same example that I gave you. Modern applications are bandwidth sensitive. So they are hungry for bandwidth. They utilize more bandwidth, correct? Due to higher user demand. So organization must upgrade with MPLS. So this bandwidth has to be increased. So if this is my setup already, okay, and I have bought an MPLS connection with a limited, for example, let's say I'm running with 1 gig bandwidth. Okay, now I'm getting huge. My business is growing. Okay, the demand is increasing day by day. Okay, now I cannot go with this. I need to upgrade. So if I upgrade, that means cost. Because MPLS setup, once it's done, it is done. Okay, so it is not flexible. Basically, main reason is MPLS is not flexible. Okay, you cannot customize it as per your wish. Once the setup is done, it's done. For every changes, dollar, money. You have to invest, okay, every changes you have. For example, deployment. Now your business is growing. You want one more branch. Again, money. It is not flexible because MPLS, you guys know, correct? You have to create a tunnel. You have to do all the configurations here. You have to build the underlay network. So it has to be set up. So MPLS, there are specific routers, correct? You have to buy the router. You have to do this configuration. You have to configure everything. Deployment issues. Getting the point? So this is most few of the limitations of working with a traditional network, specifically MPLS. Okay. So now we are talking about SD-WAN. So what is now SD-WAN and how it is good, how it is better than MPLS. So now we will talk about SD-WAN. Okay. So what is SD-WAN? Software defined wide area network. Okay. So this statement says it all. It is an overlay architecture. So first thing, what is overlay? What do you understand by overlay and what is underlay?
Overlay becomes an extra layer
Hmm.
the existing bit. Analyze the next
Okay.
system.
Okay. What else? So let's say these are my branches. So they are connected with ISP. So this is my router 1, router 2. Okay, far off location. So this is my ISP. So there may be multiple routers included here. Okay, multiple n number of routers. They may have all their setup. Okay, so ISP private public network. So what do we do here? So this is, let's say this is my Bangalore location, and this is my Mumbai location. Okay, so now once we have configured, so I have, let's say 100 networks, LAN networks behind this router. Here I have few 200 networks behind this router. Okay, so now what will you do? Will you advertise this 100 networks towards the ISP? So what do we do in this case? Mm-hmm.
Can you repeat the question?
NAT will not, NAT is just for accessing the internet. I'm talking about routing here. So will you share this networks? So how do we say, what will you do here? So we are talking
VPN.
about
VPN, tunneling.
tunneling, correct? We will create tunnels. So let's say I've created a tunnel here, VPN. Let's go with the basic. So I've created a tunnel. From router 1 to router 2, I've created a tunnel. VPN tunnel, basically. So this will be my private network, correct? I will be using a private network here. So will this tunnel work without this? So can I say, okay, now I have a tunnel, let me remove this connection. Let me delete this connection. Can we remove this? No. This is required, correct? So we give a default route from here, basically. So towards the ISP, I will always have a default route just for physical connectivity, just for the reachability, correct? And then we will have this tunnels. I will share all this networks privately. So this will be my private interaction, correct? So this setup that I have with the ISP is my physical connection. We have cables here, we have devices here. This is physical connection, correct? And basically, how my data is going? Basically, my data is going like this, logical, isn't it? This is my physical connection, what we have, basic infrastructure, you can say. But how am I forwarding the data? Like this. It is encapsulated, correct? GRE tunnel that we build up, correct? So my data is going from here. So this is my logical tunnel. This is my physical infrastructure. Correct? All agrees? Okay. So this is my underlay. Underlay means the physical infrastructure, what a setup that you have done. Okay. This is overlay. Logical. How actually the data is getting transferred. Logical. That we cannot see, we have to imagine. Logical is imaginary. This is what the actual setup is. Infrastructure. Okay. So this can either be ISP, this can also be MPLS. MPLS, basic infrastructure, you have to buy the routers, you have to create this circuit, MPLS circuit, that is underlay. Overlay. Now, if I want to give you a better example, underlay is basically related with trains. Now, trains, if you want to travel from Bangalore to Mumbai, so if you prefer to go via train, so train means it requires a basic setup first. It requires a basic setup. It requires the railway track, correct? You have to have a railway track in place. You have to have the setup. Train cannot go. It is not flexible that it will go to any route, correct? It will follow the track that we have given it. So that is underlay, that is MPLS basically. So you have to build the infrastructure, you have to give the route, label switching, and it will follow that route only. Overlay is like your flyovers. Flyover, and there's a bus running on a flyover. So bus, it can take any route. If the bus understands, okay, this line is busy, there is a lot of congestion in this particular route, I can change my track. Correct? That is overlay. So basically, this train is an MPLS setup. This is your SD-WAN setup, just to give you an introduction. Getting the idea now? Okay. So this is what is SD-WAN is all about. It's an overlay architecture. So the moment you hear the word overlay, logical. Okay, something which is above. See, something like this. This is my basic infrastructure here. Okay. So think about how my data is going. Something that is above, logical. That is overlay. Okay. So it's an overlay architecture used to efficiently manage, automate, and deploy. Okay. Manage means you can manage all your devices. You can automate these devices, this infrastructure. You can even deploy. What? A WAN based on SDN principles. Okay. Now, what is SDN principle? SDN principle is separating the control layer from data plane. So it's an architecture which on a WAN network, which separates basically, to summarize this statement. So it's an architecture which takes out the control plane from the device and it efficiently manage, automate, and deploy it. How? On an overlay architecture. Understood the statement?
Ma'am, effectively manage and automate is the thing that we can do on an existing network, right? So this underlay network will be the physical devices which we will be using in a network. But
so the word efficiently makes a difference here. So I'm not saying, it is not that before SD-WAN, we couldn't manage.
Correct.
We could manage. Without SD-WAN, we could automate. Without SD-WAN, we could deploy. But what is SD-WAN doing? It is augmenting. It is enhancing this ability all at once. It is enhancing basically.
From a single pain point, that single dashboard. Okay.
Yes. From a single click, we can do it faster. Getting an idea? Okay. So this is what is SD-WAN. So see, this picture says many things. Okay. So your location, it can be anything. Okay. So you can be in a campus. There could be a data center. You can be an industry, a MNC company. Okay. Small office, home office network. Or you can also work as a cloud-based. All your infrastructure is in cloud. So the location can be anything. Transport can be anything. Okay. So transport, Here, MPLS, internet, these are called as mediums, basically. So here now, as I said, SD-WAN uses MPLS, but it is not only dependent on MPLS. Okay, so it can you go with internet. Okay, you have internet setup. Okay, fine, I can work SD-WAN for you. You are working on MPLS, I can set up SD-WAN for you. Oh, you are working on mobile internet, no problem. You're using satellite, good. Any transport, SD-WAN supports. So this transport could be anything, doesn't matter. And what service you want from SD-WAN? What service you want? You want to do configure routing? Okay, I'll do that for you. You want to analyze your data. Analyze means, for example, just I want to give you SNMP. What does SNMP do? Monitoring your data, correct? SNMP is Simple Network Management Protocol, correct? It monitors, it keeps it like SNMP, the moment you hear SNMP related with CCTV cameras. So it is constantly monitoring your devices, correct? It is checking the health of your device, interface gone down, interface came up, HSRP state changed, okay? It is receiving so much of traffic, congestion. So everything this is tracking. SD-WAN also can do it for you. No. Oh, this is not a switch. Don't say this as a switch. So basically what we are connecting, creating a logical topology. So it could be a multi-layer switch also. It could be a router also. So no, don't consider this as switch. So this is basically a device. So where we have created a tunnel. Okay. So yeah. So so we were talking about analytics. So now we manage it as a tool. It has various tools. Analytic tool also. Okay. So with one click, we can see which all routers are not, which all devices not, I will not use the term router, which all devices is not working. Okay. Well, what if the interface is down? Why the interface is down? So it gives you a complete dashboard basically. Okay, so once we will start the lab, I'll show you the dashboard. Okay, we will see all of that dashboard, whatever we manage, we will see. Okay. So it can help with the analytics. It can give your cloud infrastructure as a service. So yesterday we discussed what is infrastructure as a service or Azure. You can build. Okay. So SD-WAN can provide that kind of service as well. Segmentation. What is segmentation? No, this is Viptela. Meraki is for small network. If your network is very small, so Meraki, as I said, it is similar, but Viptela, you can say it is more advanced. So Meraki, it is used for a small, if you have a small WAN network, so you can use Meraki. It comes with limited features. So what we are discussing, this is Viptela. All right. Segmentation. What is segmentation? Not layer 4 segmentation. I was waiting for that. So segmentation means segmenting the traffic. We're talking about traffics over here. Segmenting, keeping my traffic separate. So you must have heard about VPNs 0, VPN 512. Correct? What is VPN 0 used for? Transport. VPN 512, management. So if you don't know, don't worry. We will be talking about VPNs. So basically, VPN 0, it separates my transport traffic. Management, it keeps my management traffic separate. Okay. To give you a better example, we all know what is VLAN. What does VLAN do? Separate network. Basically, it segments. For example, if it's an HR, you have created an HR VLAN, you have created sales VLAN. So will the HR VLAN, this traffic interfere with this traffic? No. Basically, what you have done is you have segmented. That is segmentation. It keeps the traffic separate. It keeps the transport, all the services, traffic separate. And this, the best part is this is all inbuilt. So we don't have to create VPN 0. We don't have to create VPN 512. We don't have to create anything. This is all inbuilt. We just have to configure. VPN is already inbuilt in vManage. We don't have to do anything. Okay, so it is a complete package which comes with automations, which comes with all these inbuilt features. We just have to enable it. Okay, security. It provides security. Okay, so basically what happens is how? So when I say you can manage from everything from centralized management. Okay, so there is a centralized management. So this is where my controller is. This is my infrastructure. So this can be any location, means you can sit in Dubai, you can sit in Canada, US, UK, India, anywhere, go anywhere. Okay, your devices, your location can be anywhere, use any transport. You communicate however you possible, and you can manage your your controller. It can be in cloud. This can be completely in cloud. Now it depends. You can have this controller on your premises. You can build it on the cloud, and it can be multi tenants also. Multi tenants mean you can create. It's not like for redundancy. It's not like you will only have one vManage. You will only have one Smith Smart. No, you can have more than one. Okay, so there is no restriction basically. Okay, and how will you take the access of this controller? Sitting at home. You sit at home. Work from home. Sit at home. Take the access of your controller from the cloud and do set up whatever you want to do. You don't have to go anywhere basically. So that is the beauty of SD-WAN. Okay. So what happens is security. So I want to introduce a term over here. So what happens once you have, introduced, once your basic setup is done, which is called as skinny configuration. So we will talk about that. So ignore this at the moment. So basically, once you have set up, once your SD-WAN is set up, okay. So what they do is this becomes my underlay. Whatever transport we are using becomes my underlay. Okay, so this will just for a physical connectivity. After that, my controller, this is all my controller, they form a tunnel, secure tunnel, automatic, with each other, with all the sites. They form it with vManage, they form it with vSmart. So what is this? I will tell you. So basically, all of them are connected. Okay. They also form a tunnel amongst each other. Basically, everything is connected with everything else. So redundancy, they will also be connected. Redundancy is there. Okay. So I'm purposely doing this, purposely creating a mesh over here. Okay, so they are also.
Ma'am, your voice not clear.
It's not clear. Okay, just a minute.
No,
Okay.
ma'am, your
Yeah,
voice is
ma'am, he's
clear.
clear, but
Your
I think
voice is okay.
his network is down.
Okay,
Yes,
just
yes.
a minute.
Your voice is okay.
Okay, just a minute. Let me check. Oh, the network. Okay, for few the voice is okay, for few the voice is not okay. Just give me a minute. I will connect to second floor. Just a minute. Am I audible now?
Yes, ma'am.
Yeah, ma'am. Yeah, now it's clear.
All right. So yeah, let's continue. So see, so as I was saying, once the basic configuration, the skinny configuration is done, your vSmart, all the controller, they form a secure tunnel with all the what do you call the data, what do you call your sites. Okay. And the sites also, they are connected with each other. They also communicate with the help of the secure tunnel. It's a DTLS tunnel. Okay. So we'll discuss what is DTLS. Okay. So they all are configured. This is your overlay, basically. Okay. So they form their own tunnel. There is a DTLS tunnel which works overlay. Okay. And they are connected with each other. Okay. So how does it look like? Mesh. But here we don't call it mesh. Now we are advanced SD-WAN. So SD-WAN uses a special term here called as fabric. Fabric. Okay. So this is called as SD-WAN fabric. So you will come across this term usually. Okay. Deploying to an SD-WAN fabric, introducing, onboarding to SD-WAN fabric. Onboarding means introducing. If you have set up, if you have a new site, onboard it. So if there is a new site, you have to just take it to vManage, to the controller. They will onboard. Okay. So they will introduce it to the SD-WAN fabric. So this is how your SD-WAN works. So basically your SD-WAN is nothing but it is an overlay tunnel over your underlay. So underlay can be anything, internet, MPLS, 4G, 5G, satellite, anything. Okay. So this is a basic idea of what is SD-WAN. Any question so far?
Ma'am, fabric is kind for only this mesh kind of setup, means in SD-WAN terms. When we say fabric, SD-WAN fabric, what does it mean exactly?
Overlay. So just, okay. Let me show it to you here. So in the lab that we will be doing, so I have this controllers. So let's say this is my site 1, branch 1, branch 2, branch 3. Okay. Now this branch, this is connected. Either it can be connected to internet, it can be connected to MPLS. Site 1, site 2, site 3. Fine. All are connected to internet. You have taken MPLS also. MPLS connection. Okay. So this could be connected to your servers, to another site. Now, once you want to deploy SD-WAN, you want to upgrade to SD-WAN infrastructure. This is your existing setup. Now you want to upgrade this. Okay. So SD-WAN, it will introduce controllers. So basically we have 3 controllers. vManage, vSmart, vBond. Okay. So this controllers, now this devices that you have, okay, you do not have to purchase something extra. Okay. So there it uses a special term here called as vEdges. Okay, so there are two types, VH or CH. Okay, so we will talk about that. So VHS is basically, it's a software that you need to upgrade in your device basically to make it SD-WAN ready. iOS, okay, just an upgrade so that you can make it SD-WAN ready. Okay, so you can have this VHS. So this will be your core router. So what is a core device? Edge device. Edge device which connects you to the interface. So these are basically, it can either be a VH or it can be a CH. V stands for Viptela, C is Cisco. Either it can be a Cisco router or it can be a Viptela. Cisco, this is mostly hardware. It can be software also, virtual also basically. This is completely virtual. It's a virtual device. Okay, so this are called as this both specifically they are called as WAN edge device. Okay, so now once you have installed it, once you have done the basic, so initially what happens is the first. So now I'm introducing you to the components here. Okay, just I'm giving you an overview of what is this tree. So then we will discuss about what is all this tree. So once it is set up, okay, once your in skinny configuration is done. So what is skinny? We will discuss basic setup. You have to set up SD-WAN. Once this is done, what will happen is this site will create a overlay tunnel. Okay, so every device, this VHS will be connected to vManage. It will be connected to vSmart. And they will have an internal tunnel. So every device will be connected with each other. Okay, this is called as your SD-WAN fabric. SD-WAN fabric, this is nothing but your overlay network. Overlay above, this is my underlay, your MPLS or whatever internet you're using, this is my underlay. Okay, above that, they will have a special DTLS tunnel. It can be TLS or DTLS. So this is an overlay. This is called as my fabric. So all the, like, you know, once you configure, once you do some configuration here, so it will be pushed on to this devices with the help of this overlay tunnel. So I'm not going through MPLS. I'm going through the tunnel. Okay, so that makes it faster. So all my routing intelligence is basically given by vSmart with the help of protocol OMP, Overlay Management Protocol. So this will give the intelligence to all my devices, forwarding intelligence on this tunnel. Clear, Ayush?
This one clear.
Okay.
Can you repeat what you said about OMP?
OMP is now, see, this router, as I said, it is only a data plane, correct? So they don't know what is routing. I don't know how to forward. I don't have my intelligence. My brain is somewhere else. Somebody else is operating my brain. Okay. So vSmart, it uses a special protocol, which only vSmart uses. It is called as Overlay Management Protocol. Okay, so this will, with the help of this protocol, it will forward the intelligence to this device. Okay, you go via this route. Okay, you go via this route. Okay, so we talked about steering yesterday. So everything is done by this overlay management protocol. So we will discuss, we will explore this once we go at.
Okay.
So SD-WAN, as I said, go step by step. Okay, understand each and every step slowly so that we can relate to it. So we'll talk about OMP as we proceed. So got an idea. Yeah, Ayush.
Sorry.
Pattern.
for OMP we use only between VS and VH, correct?
OS, what?
OMP protocol used only between vSmart and VH, correct?
Yes, vSmart specifically. vSmart, the role of your vSmart is to forward to deliver the forwarding intelligence. Okay. vManage is giving me the dashboard to access vSmart and vBond. So we will see the rules. What is the purpose of vManage? They have a specific purpose. We will see that. So got an idea of what is SD-WAN is? Okay, just got an overview. So now let's talk about the difference. So now you will be able to relate MPLS with SD-WAN. Okay. So infrastructure. Okay. So this is my traditional WAN with MPLS and this is SD-WAN. So dedicated, it requires a dedicated physical circuit, hardware based, correct? SD-WAN, it's an overlay. Decoupled means completely virtual. This is complete virtual. Okay, so there is no specific hardware. So how do you deploy this? Let me just... So I don't know how much you guys know about virtualization. Hypervisors, you guys understand what are hypervisors?
Yes, ma'am.
Hypervisors, okay. So now, do you guys understand what are hypervisors? Okay, virtualization. How does virtualization work? So, see, you must have used EVNG or you may not have, but you have seen how EVNG works, correct? So this is my base laptop. This is my base machine, laptop. So this already comes with an operating system. So I have Windows OS. Okay. Now I want to use Linux in my machine. Or I want to use EXXI. No, sorry, not EXXI. I want to use Eve, for example. We all are familiar with Eve, so I will go with Eve example. Okay. So this now Eve as an operating system itself. Correct? So now, if I want to install Eve, okay, how should I do it? I'm already running with an operating system, Windows. So in order to install Eve, first, I have to install an hypervisor. Hypervisor is nothing but consider this as a platform, okay, wherein you can install multiple operating system. With the help of this, it will give you a medium to install multiple operating system. So in my case, my hypervisor is VMware. Virtual machines, okay, this one. This is a virtual machine. This is an hypervisor, okay. So there are many other hypervisor available. So one is VMware, then you have what do you call it? VM player, I think.
Yes, sir.
Here. Then there is
Yes, sir.
EXXI. There are many hypervisors available.
Hyper.
Yes, your Windows have already. It's already Hyper-V is installed. Windows have it. Hyper-V. Hyper-V. Windows have it. It's already pre-configured in your devices. Okay. So this, with the help of this is just a platform. So with the help of this, I can install guest operating system. I can install multiple guest operating system. Okay. So let me show you my virtual machine. So I like experimenting on this. So since I got a new laptop, so I'm not flaunting, I'm just exploring, giving you an example. So I tried installing, I've installed, see, this is my virtual machine. So this is giving me a platform. So if I want to create a new virtual machine, okay, so I've created one virtual machine, I've installed Eve over here. Then I've also installed EXXI server. Okay, so what is EXXI? I will come to that later. I will explain because basically in the lab, if you ask me for the actual environment, the actual productive environment, how will you deploy VMware? So basically, it is deployed in EXXI. Not only EXXI, there are multiple. Okay, so I will come to that point later. So now, this is my hypervisor. So I can install CentOS, Linux operating system. I can install Ubuntu. I can install Eve, whatever I want. Okay, then I can use it virtually. So this is my virtual. This is giving me a virtual platform. Okay, so this is installed. So I can open now virtual machine and I can deploy any device that I want. I can work. Okay, so this is called as type 2 virtualization. This is type 2. Type 2 means you already have an OS. Inside an OS, you are creating a virtual machine. Okay. Hosted, yes, hosting. Hosting is the right word, right? This is type 2. Now, in the office environment, when I say you can deploy VMware on cloud, okay, what does that mean? Okay, so you can deploy it on premises, on-prem, or you can deploy it on cloud. Okay, so how? On premises. Now, this is my office. I want to have my virtual machine installed in my premises. Okay, so I will have a dedicated server. I will purchase a server. Okay, so the server, it doesn't have any OS yet. So in this server, I will install EXXI. Don't ask me the full form. It is something Elastic Sky, something. Elastic Sky, something it is. Okay. So this is a server. This is again, it is a platform. Similar to your virtual machine, it gives you a platform. So through this EXXI, okay, let me show you EXXI. So I've installed it inside virtual machine only. So if you don't want to install VMware, you can deploy this EXXI server inside. The way you install any operating system, it is similar. So inside the CXXI, actually my idea was inside the CXXI, I want to deploy Eve. So that will, prevent my laptop from consuming more memory. Okay, so that was my plan, but I'm short of time actually. So this is in process. So I will do this eventually. So I was short of time because I had to take training. So anyway, I installed another Eve. So inside EXXI, you can install anything. You can install Eve. So if you go for security classes like DNAC, so it's all inside EXXI. You deploy a virtual Windows server, you deploy FTD firewall. So everything happens through this EXXI server. Okay. So it will give you an IP address 239.129. Yeah, that it will take. No, I have actually messed up with my LAN card also while I was experimenting. So, so once you install a virtual machine, it will give you this two adapters. Okay, these are called as network adapters. So basically, these are virtual switches. Okay, these are virtual switch. Take 64 GB. Then you can experiment, deploy everything.
Significant.
What a day. So this is, you will, once you deploy it, you will learn many things.
Not able to install here, there are.
Don't do that. Then forget networking, simply. So I like it doing. I never give my laptop to lab trainers. I've deployed everything from scratch. So what is the problem? So learn everything.
Uh,
Yeah, see, I got it.
you did it on 16 GB RAM of your laptop, madam?
No, it is 64.
64 GB RAM.
Yes.
So much must be a rich.
No, Rich. I'm broke now. Recently I purchased, now I'm all broke. 0.32.
No one will purchase 64 GB RAM. madam.
Because
Yes,
I'm a
64 is
trainer,
too
so this
high.
is my requirement, and I don't like using servers and being reliable. So this is, we got these EXXI server. Okay, so once you have this, okay, once you have deployed the EXXI server, so then you can monitor. So I will connect my laptop to the server, okay, and then I can access. So with this IP address, I can access. So root. What is the password? So see, this is my EXXI server. So I've not done anything here at the moment. Okay. So this is the virtual machine. You can host any device you want to. No, this is mine personal. So you can create, like once you deploy it, it will ask you to create password. Yes. So the way you deploy any server, it is as simple as that. So then you can create the virtual machines here. Okay. So see, this is the VM network, management network. Okay. So this is the switch I was talking about. So VLAN 0 and 4095 is not used. Where is it reserved? VLAN range. VLAN range is 40 to 4095, correct? It is reserved. So where is it reserved?
ESXi,
Virtual machines.
Multi-billion.
VLAN 0. It is reserved for virtual machines. So see, it is reserved. VLAN 0. It is using VLAN 0. It is reserved for virtual machines. Okay. So inside the CXXI, you can deploy. So this is how you can deploy your. So this is how the organization does. So when I say on-prem, so on a server, you create the CXXI server. Inside this, you will deploy your vManage, vSmart, and vBond, the three controllers. Okay, now it is up to you. In the same server, you can have all the three, or you can have different servers for different virtual machines. That is completely up to us, how we want to deploy. So this is called as on-prem. Now, what is on cloud? Cloud means Amazon Web Services. You have Azure platform. Okay. So you don't have to deploy this already. You have to purchase this cloud. Okay. Here we have to deploy, do everything ourselves. EXXI. Here, Amazon will take care of everything. You have to purchase. You have to pay them. Pay the rent. Okay. So it's like buying an house on rent. Okay. So this is, they are providing house, you can say, to install your VMs. Rest everything they will take care. Bandwidth, connectivity, you just have to pay the rent. So this is how the Netflix is also working. Okay, so they don't have their own servers. It is, they have purchased, I think, from Amazon only. Amazon, it is hosted on Amazon Web Services. Okay, so that is on cloud deployment. So I hope you got an idea how it is deployed and where is it deployed. What happened, Ayush? Okay, so yeah, if you have 64 GB, try installing, doing it yourself. So you will learn many things. Okay, you will learn many things, and it will improve your knowledge. No knowledge is wasted. Okay, do it yourself. So now coming back to our topic. So, as I said, infrastructure, this is an overlay, okay? If you talk about the security, MPLS traffic is not typically encrypted. We have to encrypt the tunnel by using IPsec, correct? It is not. So SD-WAN, it is already, already created a circuit, okay, and it is already encrypted, automatically it encrypts IPsec, TLS and DTLS. It comes by default. Everything is already there in SD-WAN. Management and admin. Policy changes are performed on per router basis. Every router you have to configure separately, correct? Here, centrally managed. Templates. Basically, in SD-WAN, we create templates. Okay? We will create template and we'll push this template to all the devices in just a click. Time to deploy. It can be lengthy. To create an MPLS circuit must be provisioned individually. You have to set up, you have to you have to purchase the routers, do the routing. So it will take time. It is time consuming to deploy. Okay. SD-WAN. It is faster with many full implementation. It already comes with certain pre-configuration, less time. So once we'll do the lab, we will see, okay? So how we can configure it. Once your virtualization is done, so everything vManage will take care. Okay, so vManage, it will onboard all the other devices. Okay, so I'm not getting into onboarding at the moment. Flexibility. There's a dedicated physical circuit, hardware based. So MPLS, we say it is not at all flexible. Correct? If you are introducing a new branch, you have to create a new circuit for that branch. You cannot introduce it. Here, you can easily leverage connection. It can be, here we were talking about dedicated physical circuit. So it only works on MPLS. So you cannot say like, the bandwidth here, it is fixed. So for MPLS, you have bought for 1 gig. So you cannot increase or decrease as per your requirement. Any changes you want to do, you have to pay. But here, we have choice. Go with 5G, go with MPLS, go with broadband. Go with any. Flexible. It is highly flexible. Cloud support, most important. Cloud connectivity is complicated via backhauling traffic to hub. Okay, so use this terms. Backhauling means all my site has to go via data center, DC. So everything, it is dependent. It is backhauling on data center. If my data center fails, there's a single point of failure over here. Right? SD-WAN, it is easier than MPLS with direct support for multiple cloud. Okay, with SD-WAN, I don't have to travel like this. I can go directly to cloud. Go to cloud. If you want to talk to each other, talk to each other. We have already DTLS. Fabric is already there. Traffic steering. Yesterday we talked about traffic steering, voice and data. Voice is sensitive. So, limited. You may do that. It may require add-on application. For example, load balancer. Okay. So, there is specific hardware devices. You must have heard about F5 load balancer. So it doesn't do it by default. You have to have this load balancer in place. You have to install this, do the configuration. Then it will do the load balancing for you. SD-WAN can control traffic using steering policies. So yesterday we talked about the steering policies. It automatically detects these policies. So these policies we need to create just a configuration. Then it will decide which WAN link to use. Should I go with MPLS? Or should I go with internet? It will automatically do its job. Hardware requirement, MPLS requires special Huh? Trainer's back. Second floor. मैंने ले लिया bandwidth. Hardware requirement. It requires a special router, LSR router. Okay. SD-WAN can run on any network hardware. You just have to install, upgrade the software, iOS. Okay. So it can run on, like, as I said, it can be a Cisco Edge router, it can be a VEdge router. Okay. And there are different types. Okay. So you can either you can do it all completely virtual, or you can buy hardware also. If you want to buy hardware, so you can buy that also. Completely flexible. Okay. Bandwidth limits. MPLS bandwidth is configuration dependent, limit on how much capacity it can provide. This is SD-WAN. It offers high speed. It is highly reliable and highly redundant. Okay. So this is how it is better than MPLS. So any questions so far, whatever we have discussed? So shall we talk about controllers, or shall we wind up? Wind up? Okay, fine. So tomorrow we will start. I will introduce you to the lab. So along with that only, I will introduce you to the controllers. Okay, so let's do along with the lab only. So we will talk about what is this controllers and what is data plane. So tomorrow we will start with the lab. Okay, so any doubts, any question you guys have, you can ask me, or anyone who is not received the drive access. No. Drive access I've already shared for SD-WAN. You received it? No?
No, ma'am, I did not get it.
Okay, just a minute. Where is my tracker? My tracker is also not in place. Abhijit, see, your name is not there. Okay, so for this, guys, I have shared. So just share this information. I will, Sumit, just share this information, name, email ID, and contact number. I will add.
Sure, ma'am. Sure. Yeah, sure.
Abhijit, right? Number, Abhijit?
776.
7676 8. Okay.
8096.
Email?
APKR.
I think I should have it. We were in now 8 switching batch, right, Abhijit? Or this one, right?
No.
Ma'am, one thing not regarding this SD-WAN, just in general, like Ethernet technology, we have an InfiniBand also, right? So is that technology used in the enterprise networking, or it's for different?
Which network? I didn't hear it.
InfiniBand.
Infi?
Band. One second.
Infi band. I am not sure about that. I need to check on this, Ayush. So
Okay.
you always, come with some new concept. So
No. Someone asked me that one, so thought I'll just ask you.
InfiBand. Okay, I am not sure about this. I will check and I will get back to you.
Got it.
Okay. So yeah, I will share the drive access with you, Sumit and Abhijit. So yeah, I'm done for today. If you have any queries, question, you can ask, or else we can wind up. Okay. All right, then. I'll see you guys tomorrow.
Thank you, ma'am.
Thank you. Syed Abdul. What have you done, Jayasurya?
Automation class, like we need to install VMware. So in the VMware, we have to import the various items.
VMware.